Hi children, so in the previous video we discussed the problems from 1 to 8 no. So in this video we are going to discuss the problems from 9 onwards. Okay, so let us see that the 9th question. In a triangle ABC, here is equal to not there. So in a triangle ABC, so draw the triangle ABC. In a triangle ABC, first condition they given that AD is perpendicular to BC. AD is perpendicular to BC. Perpendicular means here angles. AD is perpendicular to BC. So first here they given the condition is angle D is equals to angle D. First condition they given that angle D is equals to angle D. Next, angle B is equals to angle C. They only given here angle B is equals to angle C. Next, AB is equals to AC. AB is equals to AC. So, AB is equals to AC. So, here this is related to which axiom here? Angle D is equals to angle D. Angle B is equals to angle C. And here AB is equals to AC. So, here they are saying that angle B is equals to angle C. Next, angle D is equals to angle D, and here AB is equals to AC. Okay, so that is related to which congruency? Here two angles and side. So two angles and side means that is ASA property. Okay, so angle, side, angle. That's why here that is ASA property. Is it clear, children? Yes. So next one. So next see here, state the axiom under which triangle ABC is congruent to triangle PQR. They only given that here two triangles are there, two triangles also congruent. They only saying means those two also having same size and same shape. So that's why here they given the condition triangle ABC is congruent to triangle PQR. Now what they are asking, according to that by which axiom those two are congruent we have to say. So here measurements not given no. So that's why just see that the second diagram here 4 centimeters, 2.5 centimeters, 3.5 centimeters. So obviously actually here this is P, so this is also P. Okay, it's opposite, we can take that. Next here this is R and this is Q. If you take like that means those two are congruent, but here no need to take those all, just by which congruency only they are asking no. So that's why here they given which measurements, angles given or sides given, only sides given no. How many sides given? 3 sides measurements also given. So that's why here that is related to triple S congruency. Why? Because 3 sides measurements they given. So that's why here that is related to triple S axiom. Is it clear, children? So let's see the next one. Here two triangles cannot be proved congruent by, already we discussed that. Okay, by using that 4 axioms we can say that those two triangles are congruent, but here we cannot say that only taking angles, maybe their angles are equal, but here there is a change in its size, so we can't say that those two are congruent no. So by using that triple A property we cannot say that those two triangles are congruent, we cannot prove that those two triangles are congruent. Is it clear, children? Okay, see the next one. So this is also like that only. So in triangle ABC, AB is equals to AC and AD is perpendicular to BC. The property by which triangle ADB is not congruent to triangle ADC. So here given measurements they given, no need to find that any other thing, just we have to say that that is related to which property. Okay, so here some conditions given, according to that conditions we can prove that those two are congruent, those two triangles are congruent. So by taking that SAS property we can say that congruent, and triple S property also we can say, RHS property also we can prove that given triangles are congruent. But here by taking only angles, by taking the triple A property we cannot prove that given conditions, here triangle ADB is not congruent to triangle ADC. Okay, so let us see that next one. So children, see that next question. First assertion is two triangles are said to be congruent. They are saying that two triangles are congruent if two sides and an angle of one triangle are respectively equal to the two sides and an angle of the other. Okay, they are saying that two sides and the angle of a triangle are equal. So they are saying that two sides and the angle, not included angle. Okay. So what I told you, that if two triangles are congruent, we can say by using that SAS congruency. Okay, two sides are given and its included angle must be equal. Okay, then only we can say that those two are congruent, right? So here included not given, no, so that's why here assertion is false. Okay, so next thing, here two triangles are congruent if two sides and the included angle, here they mentioned, see here, and the included angle of the one must be equal to the corresponding two sides and included angle of the other. Then which of the following statement is correct? So in that first statement they didn't give that included angle, only angle they given. How we can say that those two angles are equal? Okay, those one of the angles are equal, included angle equal or not? How we can say that? Okay, so that's why SAS congruency means what? Two sides and its included angle must be equal, no? So that's why here assertion is wrong, but here reason is correct. So here A is false and R is true. So option A is correct here. Is it clear, children? So let us see the next one. So children, see here. State the property by which triangle ADB, okay, is congruent to ADC. These two are congruent, they are saying in the following figure. By which axiom or by which property they are asking. So what conditions they given? First to see that here they given that these two angles are equal, no? So AB is equals to AC. AB is equals to AC, first condition they given, and here its included angles are equal. So see here, AD is equals to AD common side. So AD is equals to AD common side, and here included angle A is equals to angle A. So here two sides and here one angle, so that is SAS. Included angle, no? So that's why that is SAS congruency. Okay, so which one is that? So that is first one, SAS property. We can say that these two triangles are congruent. Okay, so let us see next one. So children, see here, triangle formed by joining midpoint of sides of equilateral triangle. So this is that equilateral triangle, no? And here midpoints means these points, one of the midpoint divides that side into two equal parts. Okay, so here we can say that AD is equals to DE, and in the same way BD and here DA also, DF this is. So these two also having that same measurements only, no? And here we can say that the triangle which is formed by joining the midpoints of each side of that equilateral triangle again forms that equilateral triangle only. So here by joining that midpoints of that each side of equilateral triangle, again it forms that equilateral triangle only. Okay children, so up to here worksheet 2 problems will be completed. Okay, worksheet 2 problems completed. So next in that next video we will discuss that worksheet 3 problems. Okay.